So, good morning, one and all. Now start in the fourth unit, reactive power control. Reactive power control. So, what is the necessity of to control the reactive power control? How to control the how to control the reactive power? So, in a power system, is expected to operated under widely varying conditions from no load to overloading to a short circuit. It is designed to operate the system at all the time at constant. So here the power system is expected to operate under widely varying conditions from no load to overload, short circuit. It is designed to operate system at all the time is constant at a voltage and frequency. So in any power system or power stations, to maintain the constant frequency and constant voltage. So in the constant frequency, we already discussed in third unit how to know what is the necessity of constant frequency. The change in frequency, how to reduces the change in frequency is already done in the third unit. Now the reactive power control. So here, so in ideal AC power system, the voltage and frequency every supply point is would be remain constant, free from harmonics. So to maintain the constant frequency and constant voltage, be free from harmonics and power factor. The power factor would be the power factor would be remain unity. So for optimum performance at a particular supply voltage, each load could be designed such as there is no interference between the different loads as the result of variations in the current taken by each one. So the reactive power is needed to transmit the real from one end to other end. The bit, but it is the value of must be within limits. So the reactive power is needed to transmit one places to another places, but be but it is values must be within limits. So the voltage and frequency to maintain the constant. So the reactive power to the transmit the real power from one end to of the line to other end, and the frequency is indicating by the active power balance. The frequency to maintain the constant, the frequency is indicating by the uh, actual power active power balance, and voltage indicating by the indicator by the power reactive power balance. So the next slide is uh, reactive power compensation in the transmission systems. What are the reactive power compensations in the transmission systems? So how the voltage is indicating by the how the voltage is indicator of the reactive power. So now the derive the equation of reactive power equation of the transmission line, qr equal to delta v into vr by x. Here the delta v is the changing the voltages, changes the voltages, and vr is the receiving end voltage, and x is the reactance of the transmission lines. So in this reactive power equation, the reactive power equation depends only the voltages. That is, x is the transmission line reactance is constant, assumed to be constant here. So qr, the reactive power is depends only the change in voltages. This is the receiving end voltage. So the above relations shows that the reactive power voltage control and reactive power control are interconnected. Now this is the voltage controller, this is the reactive power, they are directly interconnected, and the reactive power is proportional to delta V in the line. So the reactive power is directly proportional to the change in voltages, change in voltages, and change in the voltages. So reactive power is proportional to the voltage. So this is the indicating by the reactive power, indicating the voltage is indicating by the active power, reactive power. The first will be control the voltages, and to maintain the constant voltage, then corresponding to the reactive power is a compensating. So the voltage at the consumer terminals must be maintained the constant within the prescribed limit irrespective of magnitude of load, but maintain the constant voltage is a complicated problem due to the fact of the system is supplied from many sources and supply the many loads at several voltages. So the voltage of the consumers, you know that the voltage of the consumers must be maintained the constant. If you not maintain the constant, will produces the, if not maintain the constant voltage and frequency to produce the harmonics. So the harmonics are produced, then the efficiency of the transmission lines or efficiency of the transmission lines can be reduces. But the maintenance of constant voltage is complicated the problem due to the fact that the system is supplied from many sources and supply for many loads at a several voltage or levels. So this is the uh, levels levels constant in the prescribed limits irrespective of to order to irrespective of the type of magnitude of load, but maintenance of the constant voltage is a complicated problem due to the fact that the system is supplied from many sources and many loads at several voltage levels. In our next point is, in order to maintain the voltage, their prescribed values at all time is necessary to maintain the balance of the reactive power of the system. So once we maintain the constant volt within the prescribed values, it necessary it at all time it necessary to the reactive power, necessary to maintain the balance of reactive power in the system. To maintain the, once you maintain the constant voltage, automatically to maintain the balance of the reactive power. So here, balance of the reactive power, if a var generated equal to var absorbed, the voltage is flat. So var generators, once var reactive power generated equal to reactive power absorbed is the thing, but voltage is flat. If var is generated greater than var is absorbed, the voltage is goes up, and var is generated less than var absorbed is the voltage is goes down. So once the reactive power generated equal to reactive power absorbed, so observe the reactive power, that condition the voltage is flat, voltage is constant. If the volt var is generated, the reactive power generated is greater than the reactive power is observed, the voltage is, that conditions the voltage goes up. And if var is generated less than the var is observed, so voltage is goes down. Var means reactive power, reactive volt amperes, nothing but reactive powers. Unfortunately, the reactive power in the system, unfortunately, the reactive power in the system keeps on varying due to unpredictable load demands of the consumers. Hence, it's the better an idea the generator of VARs and absorbs in the consumers of VAR. So, unfortunately, the power system of reactive power system keeps on varying due to unpredictable. We will be changing the reactive powers of varying due to the unpredictable load demands of the consumers. Hence, the better idea go to install the VAR generators and VAR absorbers of the consumer VARs. So, if case of the voltage is actually the voltage is the receive the 400 kV, but the receive the 500 kV, then will be VAR observers. By using the VAR absorbers, consumer VARs, absorb VARs and install and receive the absorb the extra voltages. In case of you receive the 400 kV actually, but less than the 400, by using the var generators to daily excessive voltage will be generated, nothing but var generators. So this is by using the var absorbers and var uh, var consumer vars. So what are the generator vars? So what are the generator vars? Synchronous generators and synchronous motors, and then static capacitors, and then distributed capacitance of overhead lines and cables. And what are the consumer vars? So the consumer vars is induction motors, arc furnace, and steel rolling mills, arc welding, etc. Those are the In case of excessive voltage, receive the observe the voltages and distribute transformer inductance and distributed inductance of overhead lines and cables. Once cables in the observe the inductor is observe the reactive power, and the capacitance is the deliver the reactive power. Observe the reactive power and reactive deliver the reactive powers. Distributed inductance of overhead lines and cables. So those are the consumer wires. Is a lumped inductor, observe the reactive power, and lumped capacitor by using supply the reactive power. So capacitance is the generator wire, and inductance is the consumer wire. So those are the generate in unpredictable by using the varying the reactive power within prescribed limits by using the consumer wires, and the generator wires are using this of the transmission lines. What happens? Why voltage is varies? Why voltage is varies when power is supplied to the load to the transmission network, keeping the sending end voltage constant. Receiving end voltage undergoes the variations of depending upon the magnitude of load and power factor. So here, why voltage is varies? Why voltage varies when power supplied through the transmission, but the sending end voltage is constant, and but receiving end voltage will be varying depending upon the magnitude of load and power, because of once we give fluctuations coming, then so the receiving end voltage is varying the depending upon the magnitude of load and power factor. What happens if the voltage is sorry, and once the load at a small power factor, getter is low, voltages variation. So the power factor is varying. The power factor varies corresponding to sin pi is varying. Sin pi is varying. The reactive power is varying. So uh, Q equal to delta V into VR by x into sine delta. Once the power factor changes, the power factor is reduces. The power factor is reduces, and phase angle will be increasing. The phase angle will be increasing. The phase angle will be increasing. Power factor getter voltages variations. Phase angle is increasing, then sine phi also increasing. The sine phi also increasing. The reactive power also increasing. Reactive power is also increasing. The change in voltage is also increasing. Why happens? What happen if the voltage sources at the almost as the most of equipment, if happens the voltage varies, if the most equipment work satisfactory corresponding with their voltage within 5%, if not a performance the equipment suffers, and if the life of equipment is also sacrificed. If the reactive power, the voltage varies up to 55% only in the 5% plus or minus 5, but if the voltage varies is a very high, changes the I, then corresponding the sacrifice of the equipment of life is also sacrificed in order to maintain the constant, in order to maintain the voltage is constant. Thank you.